Let's begin. Today's December 20th, 2024, and we're solving the Daily Turing Machine Puzzle. Today's puzzle uses the following 6 criteria cards. Criteria cards 1, 7, 10, 18, 19, and 20. And the puzzle uses the blue verification cards. The code above is your way to get more information on today's puzzle by searching the code on turingmachine.info. Let's go solve. So in the grid above, we've got our 6 criteria cards. On the top row, we've got criteria card A, criteria card B, and criteria card C. On the bottom row, we've got criteria card D, criteria card E, and finally criteria card F. Criteria card A takes a look at our first digit, the triangle digit, and the Turing Machine compares it to the number 1. Should the value of triangle be equal to 1, or should the value of triangle be greater than 1? Criteria card B will take a look at our last digit, the circle digit, and the Turing Machine will let us know whether it's an even digit or an odd digit. Criteria card C will take a look at the 3-digit solution, and the Turing Machine will let us know how many 4s there are. Are there no 4s? Is there a single 4? Perhaps 2, maybe even all 3 are 4. Criteria card D will take a look at our 3 digits, triangle, square, and circle, add them together, and the Turing Machine will let us know whether it's a sum total that is an even quantity or an odd quantity. Criteria card E will take a look at our first 2 digits, triangle and square, add them together, and compare the sum to the number 6. Should the sum be less than 6? Should it be equal to 6? Or should the sum be greater than 6? And finally, criteria card F again takes a look at our 3-digit solution, except this time it'll let us know a little bit about its structure, so to speak. The Turing Machine can let us know whether there are no repetitions in our solution, as in the example 125. It could tell us that it may be a double number, a single digit repeated, as in the example 112, or it could be a triple number, a single digit repeated 3 times, as in the example 222. And remember, the objective of today's puzzle is to find that unique 3-digit code that abides by all 6 criteria cards we just described. And we're going to start off with an initial proposal of 314. So the first thing I think I'd like to test is criteria card B. Okay, so the Turing Machine approves of my choice in circle. I did pick an even 4 for circle, and since the Turing Machine agrees with it, yeah, we know that circle is in fact an even digit. So let's go ahead and type that up in our notes in section B. And we'll say that circle is an even digit. And since circle is even, let's go ahead and cross out the 3 odds. Okay. I think the next thing I'd like to test is criteria card E. Okay, so the Turing Machine approves of my choice in triangle and square. We are adding them up, so 3 plus 1 is 4. 4 is less than 6, and the Turing Machine approves of that. So, yes, it's true that the sum of the first 2 digits must be less than 6. So let's go ahead and type that up in our notes in section E. And again, that's that triangle plus square should be less than 6. And what can we say? Well, in order for our sum of the first 2 digits to be less than 6, I don't think either of them can be a 5. Because when you add 5 even to the smallest of 1, that is already greater, or that's actually equal to 6. And obviously anything bigger than 1 would be something greater than 6, both of which we can't allow if we want to restrict our sum to be less than 6. Okay, what else can we test? Well, let's go ahead and test criteria card D. Okay, again, surprisingly, the Turing Machine approves. We are adding all the digits. So 3 plus 1 is 4, 4 plus 4 is 8, 8 is an even quantity, and the Turing Machine approves of that. So let's go ahead and type that up in our notes in section D. And again, we'll say that triangle plus square plus circle must be even. And what can we say about that? Okay, so we've already established that circle must be even, and if we want the sum total to remain even, there are two possibilities. Either both triangle and square, they both have to be of the same type. Either they both have to be both odd or both even. Because in both cases, when you add two evens or two odds together, that sum is even. And of course, once you add it to that circle that we've established to also be even, that sum total remains even. So we're looking at either odd, odd, even, or an all even solution. And that does it for this round. We have completed our 3 Turing tests. We're now going into the phase where we'll be discussing how to construct a good second round proposal. So notice we did not test criteria card A, comparing our first digit to the number 1. We also did not test criteria card C, establishing how many 4s there are. And then finally, criteria card F, letting us know whether there could be some repetitions or some double digits, double or even triple digits. Okay, well, the obvious thing is perhaps maybe 314 is the actual solution. Could that be? Should we not change anything at all? Well, let's see. Remember, we are dealing with either two odds or two evens. And so I don't think triangle could be a 4. Remember, if we have triangle as 4, it would either have to be a 2 or a 4. And I don't think that's gonna, obviously it breaks what we establish in criteria card E, that the sum has to be less than 6. So I don't think triangle can be 4. And even for that matter, I don't think that square could be 4 either, because again, you would have to add it to an even. And so now we can keep the 2 2s because, there is that card that says there's a double. So it could be 2 2, but it couldn't be 3 3. It could be 1 1. So we do have either 1 1 or 2 2. And then obviously it'd be a 1 3 or 3 1. Just like in my proposal, the first proposal, 3 1 4. So let's see, what else? Trying to think, could it be a triple number? Could it be a triple 2? Is that possible with the... Not sure how that would play against the... If I know there's a triple number, it would have to be all 4s, I guess. I'm not sure. Well, no, not necessarily. But one way or another, they're all 4s or none of them are 4s. Let's see. Anything in the criteria cards that kind of lend themselves? Well, let's see. Let's say there is a single 4. I guess that could play out. And I'm trying to think of how would criteria card A play out. If triangle is a 1, then it forces square to be a 3, and then criteria card C will let us know, well, is there a 2, is there a 4 or not? Basically, leaving us with a 2. So that's possible. What if it's greater than 1? Well, if it's greater than 1, I guess you do have some possibilities, right? It could be a 2, which would be a 2, 2. And then, I guess, I don't know, it could be a 4 or maybe even a triple. You could have 2, 2. And then if it's greater, then it would be 3, 1, 2, 4. Would those all be ambiguous, though? If triangle is greater than 1, it'd be 2, 2 or 3, 1. And then criteria card C will let us know whether we have a 4 or not. Let's see. Is there a way to distinguish 2, 2, 4, 2, 2, 2, and then 3, 1, 2, 3, 1, 4? Actually, let's see. Maybe we should think about it this way. What if it is equal to 1? If it's equal to 1, it forces square to be 3. No, not necessarily. You could have 1, 1 or 1, 3. So maybe for that fact, we can say maybe that is an ambiguous case. If triangle is 1, but we also have criteria card F letting us know whether there's a double or not. Okay. So if there's a double, that would mean it'd probably be 1, 1, either 2 or 4, 2, 2, and a 4. So do we have a double or not? What to pick? Three, 1. You know what? I think I'm going to keep it as 3, 1, 4. I'm going to take a risk and see where did that leave us. All right. Well, part of the reason for choosing or keeping the 3, 1, 4 is that there are no repetitions. So let's go ahead and test criteria card. Well, let's see. Could we deduce? Yeah, I don't know. I don't think we could deduce even if triangle were bigger than 1, because you could have 2, 2. Let's go ahead and test criteria card F. Okay, yes, so they are all distinct. Okay, so let's actually type that up, and we will say that the solution has no repetitions. Okay, so we know that they are all unique. So if there is a 4, it's got to be, just a single 4. And let's see what else. So they are all distinct. Could you have, again, you would still have to have 2 of the same type, either 1, 3 or 3, 1. You couldn't have, so would that mean that you can't have a 2 in triangle? Because that would force you to pick another 2. So yeah, I think you can actually cross out the 2s. Let's see. Yeah, because if triangle's 2, square would have to be 2 and vice versa. There's no way around it. Yeah, so I think we can safely cross out the 2s. That's interesting. Okay, let's see, what else? So then we know we're dealing with either 1, 3 or 3, 1. The question is, which one is it? Is it greater than, or is triangle greater than or equal to 1? And I don't think there's any way that you can deduce that. I don't think. Because 1, 3, 2, 4 work. 3, 1, 2, 4 work. Yeah, we'll just have to test criteria card A. Okay, yeah, so triangle is greater. So I think it's going to come out to be, yeah, 3. Well, it could still be 3, 1, 2. So let's not get ahead of ourselves. But we will say that triangle, because 3, my triangle 3 is greater than 1. Yeah, triangle has to be greater than 1. And so we can cross out the 1 in triangle. And because we have no repetitions, square cannot be a 1. Oops, sorry. Nope. It can be a 1. Square can't be a 3. We've already established triangle to be the 3. And so, yeah, now, is there a 4 or not? And let's go ahead and test criteria card C. And yes, look at that. It is exactly 3, 1, 4. Okay, so very interesting. I think there have been maybe other puzzles with a 3, 1, 4 solution. And I don't remember if I did switch or not in the second round. But I think that's pretty interesting. Okay, well, let's go verify. But, having all the check marks for the same identical proposal, it's pretty obvious that, yes, the answer is 314. I guess that's what I was sort of alluding to before, and that, pretty darn sure that it is correct. There we go. And how did we do versus a Turing machine? Well, it is a 6 criteria card puzzle. We did all 6 tests. No repeats. We did BDE in the first round and the remaining 3 in the second. So BDE, and pretty easy to remember that they were all correct. And let's just see how we did versus the Turing machine. Okay, wow, we did beat the Turing machine by 1 question. Well, what a, sort of lucky choice here. 314 had to hit eventually, and it turned out perfect. So I forgot to put down in C here, but obviously there was a single 4. Well, how about you? How did you solve this? And let us know if you've ever picked your first proposal, and you played it out into the second round. You kept it the same, and did you get all check marks? Whether you tested all the criteria cards or did you deduce anything? Have you ever hit a bullseye, so to speak? Let us know. If you liked the video, please do give it a thumbs up, so that more people can find the channel. And of course, don't forget to hit subscribe to not miss out on any future videos. Well, until next time, have a great one.